My name is Anton, and I played League until they introduced anti-cheat, because it doesn't support GNU/Linux. Let me tell you something about the V programming language. It will take me an hour to learn, because I started 2 years ago. It will take you about a weekend. If you realize that you will have to spend more time, how early should you start learning? I think it might be one of the candidates to replace C++. It emits human-readable C, meaning you give it V code and it outputs C. Later it will generate its own binary, but the idea is the same. V can be used interchangeably with C. The effect is a new syntax for C, and you are still binary compatible with everything else. Now you might ask, but Anton, what are the actual improvements making the language worth? Well, the project is open source. Implement whatever you like, and here's a list. We have safety. Instead of a borrow checker, which is a big step and maybe cumbersome, I don't know, we have bounds checking, we have statically typed variables and a bunch more things which give you a bit of a framework to be pretty safe in your variables. We got some sponsors, we got performance. Interop with C, since it's C code in the end, yeah, makes sense. Easy to build compiler. It's fast. Now, a big question for most game developers is, how do you deal with memory? And I'm happy to say, you can simply remove or deactivate the garbage collector, if you wish. There are multiple ways to deal with memory, and there will be more in the future, I imagine. Now we have C translation. There was a big example project for Doom, where people wrote a tool to take C and translate it to V. It works, but it's still buggy, but it's a nice feature. Hot reloading you might need sometimes while developing games. I imagine you have moving objects on the screen, which is your game state, and the function, which is your game logic, which gets a live attribute. This is a special case for the compiler, and it simply means you can update the function while the program runs. Internally, I guess it's simply separating state and logic. If you want to make games again, of course you need some graphics. If you want to make an email client, you need a GUI, and it's all OS or operating system independent. Easy cross-compilation and painless deployments. The interesting thing here is you can have multiple ways of distributing your libraries or projects. Central repository, VPM, we can take a look at later, which simply publishes user-developed code in form of a module. You can install from URL or from the central repository just by name. Pretty handy. Also you can pass production flag, which means code will be optimized. REPL for quick experiments. This is an interactive shell for V. Useful for experiments. You can calculate things quickly or download some timestamp. Now, a core feature is formatting. We all know how people react regarding style of code. Where do you put the scope? Where do you put the, I don't know, how many indentations, space do you need, whatever. It's all style which we don't need to worry about. It's simply all done by FMT. What it does is takes your compilable code, builds an internal syntax tree, and spits again out formatted code. So basically you don't need to worry about style ever again. But of course tastes differ, and I would like to change some things, customize some things which will not be possible. This is one thing you might think about, but I think it's worth to simply forget about styles. There is not only a C backend, but there's also JavaScript, Wasm, Go. You can implement more backends. The effect is pretty obvious. You can write V code for any system supporting any language if you can build the backend. Test, also a big one. Whenever you open a ticket like a bug for a V, people fix it and also test it. They implement a test, meaning every fix they do is already stored as a test. And you won't have to worry about this same thing breaking in the future. It's pretty easy. Whatever function you want to test, you simply append or prefix test. Usually they're put in a separate file, but the implementation is very simple. If you want to build websites, you want to deal with routes, you want to pass parameters, you want to return a web block, you want to send HTML, all this is possible with a framework called Web. It's one of the niceties, basically, which you don't have to re-implement yourself or take an external. It's all included in the language itself. It has an object relational mapping, not model mapping, which simply means you can define your structs which correspond to tables on a database. The idea is that you deal with local structs and manipulate or whatever you need to do, and then the framework deals with synchronizing with the database in an effective manner. Now there is much more, but let's take a look at some syntax. Here we compare C++ and scroll down a bit to, let's take this example. On the left, my personal brain is preoccupied by reading through namespaces, types. The actual thing this whole text is about is f. Assign it to text. On the right side you have the actual thing about path. You notice there is one namespace, the function you want to call, otherwise error. And all the other things around this f, in my opinion, are, well, let's say make it hard to read. Because you have to read through all of this to get to f. Now this continues with multiple examples. The most prominent I see is key map, where you have all these types and namespaces on the left side. It's simply missing on the right side. I think it's a big advantage to free up brain capacity, to not focus so much on types, instead on focus on the thing you want, functionality. I would like to show you some projects. Here we have awesome V with the perfect logo, of course. Nothing unusual for V. You can simply browse through this. I think, yeah, 4 months updated. Pretty, read me last week, pretty up-to-date list of awesome projects. Maybe we can look at some games. How about puzzle vibes? Okay, jigsaw, okay. How do you run it? Like this. How do you download it? Like this. I guess we simply clone this thing. And see what happens. How was it called? Puzzle. We run the whole directory. Let's see what happens. Okay. Hello again. Looks like I had issues with my recording software, but I got it to work, easy peasy. Did some adjustments, and let's take a look. Perfect score. Enough games, let's look at some code. Here, first of all, thank you very much, Lars Pontoppidan, for your nice contribution to the V community. We have keyword module and the name main, which simply means any file in the same module has access to the same types. So, for example, app is not defined here, somewhere else. Import is equivalent to include in C++. Here we simply give it an alias as shy, because maybe we don't want to write everything. Live was used for development. Functions can be public. They got a keyword fn. This part means it's a function on a struct. The equivalent would be a method on a class. Then we get the name and parameters, which in this case is in float 64. Variable declarations are first written with colon equals. It's a nice way to distinguish between initialization and assignment. You can pass named parameters to functions. You can comment multi-line, and you can do the usual things you can do with C and C++. This should be relatively simple to read, but let's go down a bit and find something more interesting. For example, how do we format text in V? You scope it in $ brackets, and any expression inside, which should return a string, of course, will then be put at this position in a string, which is a nice way to format things. If we continue, we find a match or switch case. It simply handles all variations of key and handles them separately. The equivalent would be if else, but it's simply shorter in this form. If we want to look at app and find out the definition where it is defined, V supports the language server protocol, meaning every editor who supports the LSP can also deal with go-to definition. Like in this case, we find it here. We find in app.v. Imagine I would like to know what heap does. It's some kind of attribute over a struct. And the first thing I would do is actually go to the docs. Let's type in heap. I have no idea. Go to built-in. Well, it's not here. But at least I can show you this whole documentation is generated automatically from the code on GitHub. We have another doc. You find it on GitHub. And let's see if we can find something like this. Heap, right here. It's under attributes, stack and heap. Where is attributes? Never mind. Here it simply says what it does. The solution to the dilemma is the heap attribute. You can read through this yourself. This is a whole bunch of documentation which is pretty concise. If you're interested in a more verbose list of features, we can check this out. Let that sink in. Since everything is open, we can simply click on vlib v and go to tests. Since everything is tested, we can also check for usage. Basically, what do we want to know? What do we have here? Function optional arguments alias. How do we write optional i64 aliases? This is the way. Go to, oh, let's see. You can have go to A, which is here, but I think it's only allowed inside the scope. It jumped to another spot in the same scope, which is fine compared to the global go to. What else? Yeah, you can have multiple return types. This is the replacement for try catch. Since somebody will have to handle the error case, in try catch this would mean propagating the error up the chain. Here we can basically go through every feature and look at exactly how it's done. Now you might say, yeah, well, V is nice, but how do I get rich quick? Well, pretty easy. But it needs to be done carefully and in small steps. First, you want to decide if you want 1 billion money. Is it worth standard output stream iterator of int? Then afterwards just imagine the software you would like to buy yourself and develop it.